So we call this one a special case because it's a perfect square trinomial, but really, like, there's nothing about it that's different unless you start to recognize a specific pattern. So we're going to approach this the same way, meaning I'm going to notice that I'm trying to factor this thing, so I'm trying to find two things that multiply together to give me this as an answer. There's no common factors among these terms, among all of them. And so I'm going to have to open up two parentheses and think to myself, two things that multiply together to make m squared, and two things that multiply together to make positive 9. So for the m squared, there's one choice, m and m. For the 9, it could be 9 and 1, it could be 3 and 3, we just don't know. So if I think about that 9 and 1 for a second, though, I realize that 9 and 1 is out of the question. Because if I have a 9 and a 1, they're not going to combine to make 6. There's just no way. So if I do 3 and 3, I'll notice that, yes, I get a 3m, I get another 3m. These can totally combine to make a positive 6m if they're both positive, and if they're both positive, I'll still get that positive 9. So that's my final answer. But it's the same thing twice, and I should probably then write my answer like m plus 3 squared. There's a pattern here that you might recognize if you know your square numbers well. It's numbers like, here square numbers are like 1 and 4, 9, 16, 25. If you've never seen these, this is 1 times 1, this is 2 times 2, 3 times 3, 4 times 4, 5 times 5. So 36 is 1, 49. If you know those numbers well and you notice them at the beginning and the end of a problem, then this special case might be in play. And the way you know for sure is basically if whatever you square to get this, which is m, whatever you square to get this, which is 3, if that middle term is twice as big as that thing, this is a perfect square trinomial, and you can jump to this answer right away. I would not recommend doing that right now, but just kind of look out for that pattern. And anytime you get a situation where you have the same thing twice, just do a mental check. Is the square root of this and the square root of this, which is this, multiplied together, doubled, going to give you that? It sounds terrible in words. It sounds terrible in words. But there's patterns and you'll see them. And if you don't, that's okay, because you can just do it the old-fashioned way. I didn't see these types of patterns until I was probably like in my 3rd year of grad school. Okay, that's a lie. But still, you get the idea. It's a shortcut if you see it. If not, do it the long way. Good luck.